Good morning, students. I hope everyone is fit and fine and you are following the guidelines being issued by our government from time to time. Yesterday, I have posted one lecture in this group that was Chemistry of Heterocyclic Compounds. I hope everybody has gone through that lecture and you have noted it down in your copies. So we'll be dealing with the details of heterocyclic compounds in this lecture and in the coming lectures. So far, I think you have studied only about the carbocyclic compounds, and this is the first time you'll be dealing with heterocyclic compounds. So, as an introductory lecture, let me first discuss what is the difference between carbocyclic compounds or homocyclic compounds and heterocyclic compounds. Organic compounds broadly can be categorized into two main subdivisions. One is carbocyclic compounds and second is heterocyclic compounds. Carbocyclic compounds are also known as homocyclic compounds. So homocyclic compounds, if you see the word homocyclic is made from two words, that is homo plus cyclic. Homo means of the same type, cyclic means ring. So the ring which contains atoms of the same type are known as homocyclic rings. So when we say atoms of the same type, so in organic chemistry, atom of the same types means most of the atoms are, all of the atoms are basically carbon atoms. For example, cyclohexane. Cyclohexane is a cyclic compound. It is a ring which is made up of carbon atoms and 6 carbon atoms are present in a ring. So all the atoms are carbon atoms and it is a cyclic compound. So this is placed in the category of homocyclic compounds. Similarly, you have cyclohexanol. Cyclohexanol also contains 6 carbon atoms in a ring. Similarly, cyclopentadiene. These all examples have been provided in your notes. Cyclopentadiene, it contains 5 carbon atoms in a ring. Benzene also contains 6 carbon atoms in a ring, and so on. So these are all the compounds which have only carbon atoms in the ring. On the other hand, heterocyclic compounds, the word heterocyclic has originated from the two words, that is hetero plus cyclic. So cyclic again means ring, hetero means different. So heterocyclic compounds are those compounds which are cyclic compounds, but in the ring there is at least one atom other than carbon atom. Now, what can be that one atom which is different from the carbon atom? That atom can be nitrogen, that can be oxygen, that can be sulfur, that can be halogen, that can be phosphorus, and so on. So in your lectures, I have provided you with few structures of the heterocyclic compounds, and you have to memorize these structures. Once you memorize them, the things will become easier for you, especially when you deal with the nomenclature of these compounds. So I'll let you know the method to memorize them. For example, in the first line I have provided the three heterocyclic compounds, pyrrole, furan and thiophene. So the way to memorize them is pyrrole, you can see, consists of a 5-membered ring. One is nitrogen and other 4 are carbon atoms. So pyrrole is a 5-membered ring containing 1 nitrogen, 2 double bonds and 4 carbon atoms. And if you can see, the lone pair and the 2 double bonds are in conjugation with each other. So when I start from the lone pair, this is lone pair, single bond, double bond, single bond, double bond, single bond, and coming back to the lone pair. So pyrrole basically is a conjugated 5-membered ring containing 4 atoms and 1 heteroatom, that is nitrogen atom. So this is being placed in the category of heterocyclic compound. Second compound given in your notes is furan. Similarly, furan is made up of 4 carbon atoms and 1 oxygen. Again, lone pair and double bonds are in conjugation with each other. If you start from the lone pair from oxygen, you can see lone pair, single bond, double bond, single bond, double bond, single bond, and back to lone pair. Thiophene again belongs to a category of 5-membered heterocyclic compound containing 4 carbon atoms, 2 double bonds and 1 sulfur, again in conjugation with each other. Then there is a second line which consists of 5-membered rings, but now instead of 1 there are 2 heteroatoms present in the ring. For example, pyrazole is a 5-membered ring containing 2 nitrogens at 1,2 position with respect to each other, and there are 2 double bonds in conjugation with each other. Imidazole is another 5-membered ring which consists of 2 nitrogens, but now the position is 1,3 with respect to each other, and again there are 2 double bonds present in the ring. Oxazole is basically another heterocyclic compounds made up of two heteroatoms. One is oxygen, second is nitrogen, and the position is 1 3 with respect to each other. Thiazole, another 5-membered ring containing two heteroatoms. One is sulfur, second is nitrogen, and the position with respect to each other is again 1 3, and the two double bonds are of course in conjugation with each other. Next two compounds are saturated heterocyclic compounds. One is piperidine and second is pyrrolidine. Piperidine is a saturated 6-membered heterocyclic compound containing one nitrogen atom. So it is just like cyclohexane, but one carbon atom is being replaced with the nitrogen atom. Second is pyrrolidine. Pyrrolidine is 5-membered heterocyclic ring containing one nitrogen atom. Next is 3-pyrroline. Pyrroline is again a 5-membered heterocyclic compound containing one double bond and one nitrogen atom. Next is a category of 6-membered rings, which are aromatic compounds basically. So this is pyridine, which is a 6-membered ring containing 3 double bonds, 1 nitrogen. Then pyridazine. Pyridazine is again a 6-membered ring containing 2 nitrogen atoms, and the position of 2 nitrogen atom is 1 2 with respect to each other. Then you have pyrimidine. Pyrimidine is another 6-membered heterocyclic compound in which nitrogen is placed 1 3 with respect to each other, and of course there are 3 double bonds in conjugation like benzene. Then you have pyrazine. Pyrazine is another 6-membered heterocyclic aromatic compound in which nitrogen atoms are present at position 1 4 with respect to each other. And then there are purine bases, which consists of two rings fused with each other, in which one is 6-membered ring having nitrogen 1 3 with respect to each other, and second is 5-membered ring having nitrogen 1 3 with respect to each other. Now you have to memorize these structures. That's unfortunate, but with time it will become easier with you. On the next page, you have fused heterocyclic compounds containing quinoline. Now quinoline is a benzene, which is a 6-membered carbocyclic compound, and then there is another 6-membered ring in which one nitrogen is present. Isoquinoline is the isomer of quinoline in which the position of nitrogen has been changed. It is position 2 with respect to the fusion end. Then you have carbazole and so on. Now why do we need to go into heterocyclic compounds? What's the importance of the heterocyclic compounds? Heterocyclic compounds are very, very important compounds. These occur widely in nature as well as non-naturally also. These are important compounds. For example, genetic material like DNA, it is composed of heterocyclic bases such as purines and pyrimidines. In the lecture you have been provided with the structure of purine and you have been provided with the structure of pyrimidine. You can see pyrimidine is a 6-membered heterocyclic ring containing two nitrogens, 1 3 with respect to each other. And again purine, in which there is one 6-membered ring and one 5-membered ring. In 6-membered ring nitrogens, there are two nitrogens positioned 1 3 with respect to each other, and then fused with 5-membered ring, and again there are two nitrogens positioned 1 3 with respect to each other. Along with the DNA, there are various other alkaloids, vitamins, essential amino acids, hemoglobin, chlorophyll, which contains all heterocyclic rings. For example, penicillin G, the structure has been provided in the notes. It contains a heterocyclic ring. Nicotine, which is a tobacco alkaloid, it also contains a heterocyclic ring. Then thiamine also contains a heterocyclic ring. Rezapine, which is a tranquilizing drug, also contains heterocyclic ring. Chlorophyll, which is a green plant pigment, also contains a heterocyclic ring. Along with these compounds, heterocyclic rings are present in variety of herbicides, insecticides, etc. So medicinally, these are very, very important compounds. That's why we have to study and understand what their chemistry is. So before going into the details of the chemistry, we need to understand the nomenclature of these compounds. Now what is the nomenclature? Nomenclature means a system of naming the organic compounds. That is nomenclature. So there are basically two ways to name the heterocyclic compound. So there are trivial names and there are systematic names. What do you mean by trivial names? Trivial names were being provided to the compounds when the chemistry was not that developed. So, this system of nomenclature is based on the names which were given before the structures were really identified, and how the names were given when the structures were not identified. The names were given on the basis of their characteristic properties or on the basis of source from which these were obtained. Therefore, the names are basically based upon the source from where they are obtained. So they does not provide, or they do not provide, any information about the structure of the molecules. You have to just remember the names. On the other hand, the second type of second type of system which deals with naming of the heterocyclic compounds is systematic system. Now, systematic names are being provided on the basis of certain rules and regulations. So these you don't have to remember. You have to remember certain rules, and on the basis of that rules, you will be giving the names to the heterocyclic compounds. Most commonly, we use mixture of these two systems. That is, we use combination of trivial and systematic names. Now, in the notes, you have been provided with certain heterocyclic compounds with their trivial names. Almost 32 or 33 structures are there, and you have to memorize the structures. इनको बार बार लिखिए, इनको बार बार याद कीजिए. इनको याद करना ज़रूरी है, और धीरे धीरे ये याद होते भी जाएंगे once you start dealing with these compounds. But for the time being, the assignment is that the list has been provided to you, and you have to memorize the structures along with their trivial names. ये trivial names basically कोई systematic names नहीं हैं. ये उस टाइम दिए गए थे जब स्ट्रक्चर्स आइडेंटिफाई नहीं हुए थे. सो इसलिए ये मोस्टली डिपेंड करते हैं कि किस तरह के सोर्स से ये डिराइव किए गए, या फिर इनकी कैरेक्टरिस्टिक प्रॉपर्टीज़ किस कैटेगरी में फिट हो रही थी. So you have to memorize these structures, and you have to memorize the name of these structures. So that's all for this lecture. Thank you.